Alright, Track Safety Standards Compliance Manual, Chapter 5, Class 1 through 5, April 1st, 2007. 213.119, Continuous Welded Rail, General. Guidance General. Each of the railroad written procedures shall have the responsible consistent with the current research result. The FRA will review each of the plan for compliance with the paragraphs A through G. The FRA Headquarters Track Specialist, Regional Track Specialists have primary responsibility for reviewing each set of the railroad. The Continuous Welded Rail procedures inspectors may request to be provided with a recommendation concerning the comprehensive of those procedures. In addition, with safety critical procedures listed in this section, the railroad may decide to include the procedures based on administrative economic consideration. For example, the railroad may choose to include instructions that limit the use of worn second-hand replacement rail because of an economic concern about the length of the time and it may take to perform a satisfactory weld. The railroad may also include the specific actions in their procedures that have been taken when the installation maintenance work does not comply with its overall procedures. Record an activity that does not conform to the railroad's continuous welded rail procedure does not provide with the railroad indefinite relief of the responsibility for compliance when a procedure is not followed. Continued non-compliance may lead to unsafe condition. The record-keeping procedure is intended to provide with the safety net by flagging those activities of non-compliance which, if not brought to in compliance with the time manner, could lead to an unsafe condition. For example, the continuous welded rail installed in winter months without adequate rail anchors as prescribed with the written procedures discovered in later summer would clearly be a definite condition where it would whether it was recorded or not. When in doubt as what to activities considered safety related, the inspector should consult the regional track specialist. Whenever conducting inspections on the railroad, the activities include observation of the current continuous welded rail. The FRA inspector are to include the continuous welded rail P unit of the headquarters of the RISPC railroad in personal computer inspection system. Personal computer record the continuous welded rail P regardless of the amount of continuous welded wear inspected. The record of the actual track mileage using the activity codes MTH, MTW when the defective is in taking any of the statute 213.119 paragraphs 119. The defective codes the FRA inspects are also to designate the C continuous welded rail pro file for the line item activity cell. In addition, with the inspectors or with the continuous welded profile, each line item the activity cell when performing the record inspection recording the deficiencies concerning the continuous welded joint records. When conducting track inspection, the FRA inspector should have with them the most recent copy of the railroad's current and continuous welded rail plan. The importance of having this enable an inspector to perform the proper inspection to determine the compliance with the plan. The inspector can obtain the railroad continuous welded rail plans by logging on the FRA secure website, downloading a copy of the plan on the file with the FRA. When the inspector discovers a substantial discrepancy between the official plan on the file and a FRA headquarters plan on the field, or other than that substantial discrepancy between the official plan of the on file with the FRA and the railroad field manual, they should not notify their regional track specialist. A track owner may update and modify the continuous welded rail procedures as necessary as required to notify the FRA of those changes. The definition of buckling incident explains the industry definition of such of an event. However, the rules recognize the importance condition for the precursors to the buckles. The two failures modes associated with the track constructed with continuous welded rail are track buckles and pull aparts. Track buckles are considered to be the most serious of the two, and they're characterized by the formation of a large lateral misalignment caused by high compressive force in the rail, thermal mechanical loads, weakening track condition, weak track resistance, alignment deviations, vehicle or loads, dynamic wave, uplift, lateral, vertical ratios. Each track owner which constructed with the continuous welded rail shall have an effective comply with the plan with the contains the procedures which address the installation, adjustment, maintenance, and the inspection of continuous welded rail. Inspection of continuous welded rail joints and the training program of the application of those procedures. The plan should be submitted with the FRA Road Administration. The FRA reviews each plan for the compliance of the following. Alright, 119A, the procedure for the installation and adjustment of the continuous welded rail, which include 1. Designating the desired rail installation temperature range of the geographic area in which the continuous welded rail is located. The de-stressing of the procedures method of addressing proper alignment of the desired rail installation temperature range, which when adjusting the continuous welded rail Guidance. The track owner will construct with the continuous welded rail are required to have the effect with the compliant with the C continuous welded rail plan. This includes the track owner who operates in the entire continuous welded rail track that has been designated accepted to the track pursuant to the Statute 213.4. The requirements under the Statute 213.119 do not apply to accepted track. See the Statute 213.5b. However, where the railroad designates a segment of the track that is expected, it still must meet the requirements of at least Class 1 track for any portion of the track that is 1. Located 30 feet of the adjacent track, which is subjected to simultaneous use of speed except for 10 miles an hour. 2. Located on a bridge or a public street, the highway there are trains with placards. See attached to 213.4d. Railroads typically establish the desired rail installation temperature range with the geographic area there higher than annual mean temperature. The higher installation temperature will account for the expected reduction for the force-free temperature caused by the track maintenance, train traffic, and other factors. A railroad failure to establish designated installation temperature range for the specific territory is addressed under Statute 213.119a. 119B rail anchor fastening requirements that provide sufficient restraints to limit the longitudinal rail and cross-tie movements to the extent of practical, specifically addressed by the continuous welded rail anchoring faster patterns on the bridge approaches the other locations where the possible longitudinal rail and cross-tie members movement associated with normal accepted train induces force is restricted. 119C procedure with specific address maintain the desired rail installation temperature range with the cutting of the continuous welded rail, including rail repairs and track welding in the conjunction with the adjustment made with the area of the tight track with the track buckle and pull apart rail repairs. Practice styles take into consideration existing rail temperatures so that 1. When the rail is moved lengthwise installed with determining taking into the consideration existing rail temperature, desired rail installation temperature range, and 2. Under no circumstance should be rail added when rail temperature is below the designated paragraph A1 of this section with provisions of a later adjustment. 119 procedure to address monitoring the continuous welded rail curve track, the inward shift of the alignment towards the center of the curve as a result of the disturbed track. Thermomechanical loads are opposed with 3 parameters: latitudinal, longitudinal, and torsional resistance of the track. Track buckles must also always occur in the lateral direction. Lateral resistance most interest depending on the weight and size of the crosstie, material ballast, material type, and the shoulder width, crib content, and its level consolidation. Vertical loads. The crosstie's base side crib, friction, ballast, shoulder resistance contributed to overall lateral resistance. Sustains in general, each of the contributes to the base of 50%, side 20 to 30%, and to the shoulder 20 to 30%. In the resistance, but the ratios can be very dependent upon the ballast condition. Lateral resistance vary for location depending on the ballast, shoulder, geometry, cross tie, size, type, and state of the ballast consolidation. Thermal loads themselves can buckle and often are called static buckling. However, the most buckling occur under the combination of their thermal and vertical loads, or vehicle loads, termed dynamical buckling. Inspectors should be emphasized on the vehicle, the dynamic effects of the track lateral stability, while the high rail temperatures and vehicle loading could progressively weaken the track due to the dynamic uplift. Flexural waves, buckle mechanism response induced to misalignment growth. Because the majority of the buckles occur in the dynamic train movements is an important element of the buckling mechanism. Elements of the truck lateral instability include formation of initial misalignment caused by the reducing local resistance, high impact loads into initial rail surface, welded imperfections, soft spots in the ballast, and curved railed radial breathing shifting, and also misalignment growth caused by high lateral loads, increased longitudinal force, track uplifts, vertical loads, and track induced vibrations. Inspectors may consider the above elements combined with the related evidence of the actual defects, the geometric conditions, of the defective structural conditions when they are evaluating the adequacy of the continuous welded rail stability procedures under Statute 213.119b, c, and d. Locations where track buckling are more likely to occur include horizontal vertical curves, bottom grades, bridge approaches, high rail grade crossings, recently distributed track, the areas of heavy train starting and braking. The signs of precursors of buckles include newly formed alignment deviations, wavy, kinky, snaky, or etc. Rails rotation, lifting of the tie plates, intermittent loose of the tie plates, excessive running rail causing tie plates to plow or churn the ballast. 3. Inefficient anchors not tight against the tie. Insufficient ballast section of the crib shoulder areas and gaps of the cross tie ends, especially on the lower inner rail. Curves are more prone to buckling because of the curvature effect of the alignment imperfection sensitivity. The train loads the important inspector to be considered when and where the buckling may occur, e.g. the track segments of the continuous welded rail was laid below and desired rail installation temperature. There was an inadequate control of laying the temperature and adequate adjustment of the rail afterwards. Also, inspectors should observe the areas of recent maintenance involving that either the blast of the rail there was an adequate reconsolidation time and distributed ballast inadequate temperature adjustment when the replacing of the defect of the curvature increases the buckling resistance decrease, and under the same conditions high degree curvature can undergo the gradual lateral shift. Progressive buckling, lateral alignment deviations reduced by the track buckling strength and can initiate the growth in critical levels. Vertical alignment deviations influence buckling. Lateral misalignment is important consideration because it reduces the ability of the track to resist buckling. The alignment of the offset misoriented with allow limits for the grow under the imposed loads. This is called track shift. And longitudinal force curved track will cause the continuous welded rail to move rapidly. Compressive load in the rail during the summer trend of the more of the track outwards. The tensile line loads of the winter will track inward, a term known as the radial breathing. Inspectors show the review that inspectors should review the allowable limits under Statute 213.55 to evaluate relevant alignment track strength. Statute 213.13 movement under load due to the repeated thermal vertical loading. General speaking, a decrease in the force-free temperature of 30 to 40 degrees from the installation temperature can be critical and leads to direct buckling. Inspectors should monitor the following factors that may influence the shift with the force-free temperature, improper rail installation, inadequate rail anchors of the fastening, lateral movement of the curves through lining operation, skeletonized track segments, base ballast removed from the maintenance purposes. Inadequate ballast section, lateral longitudinal restraint, and influenced by the factors mentioned above, and the improper maintained to allow it to exist in defective state, and increasing the opportunity of the train buckles. Track buckles occur less frequently in tangent than in curves. However, the buckling in a tangent truck will generally suddenly and with more severe consequences. The second of the two failure modes to be associated with the track constructed with continuous welded rail is a pull part. The rail decreases in temperature in the winter and will create tensile force. The maximum tensile load in the rail is determined by the difference in the insulation force-free temperature and the lowest rail temperature. Enough tensile force can be caused to direct the fractured rail cross-section with a prior crack, weak welds, shear joint welds at continuous welded string end location. 119E, the procedure with the control train speed of the continuous welded track when maintenance work of the track rehabilitation, track construction, any other event that occurs with the disturbed the roadbed ballast section reduces lateral longitudinal resistance of the track. And 2, and formulated with the procedure under the paragraph E of the track owner shall 1. Determine the speed required duration, subsequent removal of any speed restriction based on the restoration of the ballast, and along with the sufficient ballast reconsolidation, stabilizing the track at a level and can accommodate accepted if the train-induced forces. Ballast reconsolidation can be achieved through either the passage of the train tonnage mechanical stabilization procedure or both. 2. Take into consideration the type of cross ties used. 119F. Procedure with the prescribed physical track inspection performed with a defect, buckling prone conditions under the continuous welded track. A minimum of these procedures shall address the inspection track identity. 1. Location of the tight or kinky rail conditions are likely to occur. Location with the track of work of the nature described in paragraph E1 of the section have been recently performed. 3. The formulation of the procedure under paragraph F. the track owner shall 1. Specify the time of the inspection through 2. Specify the immediate remedial action to be taken when the buckle-prone conditions are found. 119G, procedure for prescribing the scheduling, conducting the physical track inspection, detect tracks and other indications of particular failures of the continuous welded rail joints on and after January 1st, 2007, formulating with the procedure under this paragraph. The track owner shall guidance. The paragraph requires each of the track owner to include a continuous welded rail plan provision for the schedule and conduct of the joint inspection. Person will qualify under the statute 213.7b will perform the inspection required with the paragraph on 1 foot at the joint. 1. Address the inspection of the joint track structure of the joint, including at a minimum periodic foot of the inspection. Guidance. The paragraph governs 1 foot periodic inspection of the continuous welded joints. Tracks owners required to establish procedure conducting these inspections. These are on-foot periodic inspections of the continuous welded rail joints. Track owners are required to establish procedure conducting these inspections upon identifying actual condition of the joint failure. Broken, cracked joint bars are potential conditions of the joint failure where the track owners must initiate appropriate corrective action and keep appropriate records. See Statute 213.119G5 and 213.119G7. In addition, when track owners of the continuous welded rail that are not in compliance with the requirements part 213, the track owner must make an appropriate remedial action period required under 213. The inspector should note that nothing of the paragraph interferes with the track owner continuing obligation to conduct these inspections under 213.233. In addition, on the foot periodic inspections can be performed concurrently with statute 213.233. All right. Alright, we're going to start at the top of the page. Periodic inspections is referenced here, and on foot inspections continuous welded rail on the track owners must conduct on a regular basis. Track owners are required to conduct on foot periodic inspections at minimum intervals specified in paragraph G6. Track owners, of course, are free to conduct these inspections more frequently than they are required. 2. Identifying joint bars, visible or otherwise detectable cracks, and conduct remedial action pursuant to Statute 213.121. The paragraphs that require the track owner to identify the joint bars, visible or otherwise detectable cracks, and conduct remedial action pursuant to Statute 213.121. Railroad inspectors must know that distinguishing joint bars that are already cracked and joint bars that are potentially cracking in the future. When the track owner discovers the cracked joint bar, he must take a remedial action specified in Statute 213.121. However, they are discovered in a joint bar that actually potentially joint failure, he must have corrective actions specified in continuous welded rail plan. Corrective action will be further addressed in paragraph G5. 3. Specific conditions of actual potential joint failure on which personnel must inspect include a minimum of the following items. Guidance. This paragraph identifies those items relating to joint inspection for the track owners must address with the continuous welded joint rail plans. Inspectors should note that these items are the minimum of the track owners should address. Of course, the track owners are free to include additional items at the perspective of the continuous welded rail plan. Railroad track inspectors are to identify and record actions the items listed during the inspection of the joint bars because these items are related to the integrity of the joint and thus the safety of the train that may operate over these joints. Inspectors should note that this list is not all-inclusive otherwise condition that could indicate failure. Inspection should urge track owner to consider all considered conditions, not just those listed. For example, 1. Loose, bent, but missing joint, bolts, rail end battered mismatch that contributes to instability of the joint. 3. Evidence of excessive longitudinal rail movement of the near to the joint, including but not limited to the wide rail gap, a defective joint bolt, disturbed ballast, service deviations, gap between tie plates and rail, and displaced in the rail anchors. 4. Specify the procedure for the inspection of the continuous welded rail joint that are embedded with the highway railway crossing, otherwise cross structures that prevent complete inspection of the joint, including the procedure for removal of the joint loose material other than temporary material. Guidance. The paragraph requires the track owner to include the procedures in the continuous welded rail plan for the inspection of continuous welded rail joints. These embedded with the highway, railway, grade crossing, and other structures that prevent the complete inspection of the joint, e.g. the plans of the fueling facility, scales, passenger walkways at the station that cover the track, and etc. The plan must also include the procedure for the removal of loose material and other temporary material from their joint. With respect to the procedure for the embedded joints, inspectors should note that they accept the railroad disassembled for the move of the track structure, movement of the pavement and crossing pads to the conducting inspection of the continuous welded rail joints. However, we do expect the railroad will make every effort to extend the practical to inspect these joints in the structure. Inspectors need to be aware of the continuous welded rail joints may be sometimes temporarily buried during the inspection, during the maintenance, whenever the ballast is distributed in the middle of the track along the track, and therefore unavailable for the inspection. The FRA expects that the railroad will take necessary measures to conduct the inspection of the continuous welded rail joints, except that the railroad will schedule the maintenance so that to all allow the complete inspection of the joints where the continuous welded joint are buried. E.g., ballast inspectors should understand that the railroad maintenance will wait for the completion of the track surfacing, de-dressing the ballast before conducting the joint bar inspection. However, the railroad employees may use hand tools, mechanical means to remove the ballast from the side of the track joints so that they can conduct the inspection of those track joints. Finally, the FRA notes that the components of the track, such as cross ties, fasteners, tie plates, etc., are also not visible to the highway grade crossing similar structures. Inspectors should note that the FRA has never specifically exempted the items from the inspection required under Part 213. Inspectors should continue to expect the railroad will inspect these areas to the maximum extent possible. 5. Specific and appropriate corrective actions to be taken with the personnel finding the conditions of the actual potential joint failure, including on-foot full follow-up inspection, monitoring condition of potential joint failure in any period prior to the completion of repairs. Guidance. The paragraph requires that the track owner to specify in their plans the appropriate corrective action that must be taken when the track inspectors on conditions of actual potential joint failure. Inspectors should note that the difference between the terms of the remedial actions and corrective action and applying accordingly. Remedial actions are those actions which owners are required to take result with the requirements of Part 213 to address the non-compliant condition. For example, a track owner discovers a cracked joint bar, he must replace it. See Statute 213-121 or the continuous welded rail plan. Corrective actions, on the other hand, are those actions where track owners specify the continuous welded rail plans to address the conditions of the potential joint failure, including as applicable repair restriction and appropriation and or additional on-foot inspection to ensure clarity. The FRA has defined in these terms of the Statute 213-119J. On-foot follow-up inspections are referenced herein as joint-specific and conducted with the responsibility conditions that the track owner discovers during the inspection. The track owners will identify the continuous welded rail plan with the condition of the trigger follow-up inspection. For example, whichever the track owner identifies to replace the bolt, inspect the weekly as in correctively action for a bent bolt. If a track inspector discovers a bent bolt during the periodic inspection does not immediately replace it, then the track inspector will have to conduct follow-up inspections at the joint. 6. Specify the time of the periodic inspection shall be based on the configuration condition of the joint. The paragraph guidance. The paragraph requires the railroad owner to specify the timing of on-foot periodic inspection, the minimum number of the railroad required joint inspections as addressed in the table paragraph G6.1. The time periods of the paragraph represent the minimum of what is detected. Expected. The railroad owners encouraged and implement additional inspection period as they determine necessary. In paragraph G6.2 through 4, inspectors should be aware that FRA allowing the exemption to minimum inspection frequencies, unscheduled detours, certain passenger trains, and items that are already inspected on the monthly basis pursuant to Statute 213-235. Each of these inspections we'll discuss in more detail. 1. The acceptance provided with the paragraph G6 through G6.2 through 4. Track owners must specify that all continuous welded rail joints are inspected at a minimum in accordance with intervals intended in the following table. Track classes 5 through 1 are minimum of less than 2 for less than a minimum of 40 gross tons, 40 to 60 gross tons, 3 to 2, 4 greater than 60 megagrams, 4 to 2, less than 20, 3 to 2, greater than or equal to 20 million gross tons, 3. 4 is 4 has two intervals for two freight trains for the over the track of the annual tonnage of less than 40 milligram gross tons, 40 to 60. 3 freight trains track full as 4 and 4 and to greater than 60 passenger trains 2 and 3. These are 40, 60, 40, less than 40, 40 to 60 is greater than 60, less than 20 and equal to 20. 3, 1 less than 40 to 62 and greater than 62. Passenger trains less than 20 and greater than 22 and 2. Class 2 is has no freight trains with less than one number one inspection for less than 20 gross tons, greater than 20 gross tons. 0, there's zero inspection for class number 1. Guidance. The first note provides where the track owner operates with both the freight and the passenger train over the segment of the track. There are 2 different possible inspection interval requirements. The most frequent inspection interval applies. The footnote was developed to address the concern over the track shared by the freight passenger train. It was anticipated that they could potentially conflict with the inspection frequency required from the track. The track owner were to follow the chart, and both types of trains requiring more frequent inspections in situation to conflict. The footnote ensures the greater safety protection to the track used in mixed purposes. Second footnote was added to the response to concerning over the sensitivity of extremely regional weather conditions. Concern was raised regarding the difficulty in inspection of the continuous welded joints in northern regions where there are large amounts of snow. FRA notes that there could be times where it would be extremely difficult for the track owner to clear the snow and the ice from the joint in order for it to be seen for inspection. The footnote allows flexibility for the track owners in such a situation. 2. The consistent with any limitations applied with the track owner passenger train and conducting an unscheduled detour operation may proceed over the track normally used as passenger operation as speed not exceeding maximum authorized speed authorized allowed, even though the continuous welded rail joint has not been inspected in accordance with the frequency identified in paragraph G6.1, provided that all continuous welded rail joints have been inspected consistently with the requirements of the freight service. B, the uninspected detour lasts no more than 14 consecutive calendar days. In the order of the continuing operation beyond 14-day calendar, the track owner must inspect the continuous welded rail joints in accordance with the requirements of G6.1. Guidance. The paragraph allows track owners to operate the passenger train without lowering the track speed a limited period of time and without adhering to the required inspection frequency for passenger train pursuant in Table 2. In Table 213.119 G6.1, the provisions accommodates the unplanned outages, derailment, accidents, other emergency situation. Track owners are still to adhere to the applicable freight inspection frequency. The provision is intended to provide relief of the railroad to operating passenger trains that have a last-minute emergency situation. However, if the track owner operates a passenger train at normal track speed for more than 14 days, the track must be inspected with the appropriate passenger train levels as detailed in Chart 213.119 G6.1. 3. Tourist scenic historic excursion operation limited to the maximum authorized speed for passenger trains over the next lower class needed to be considered in determining frequency inspection under the paragraph of G6.1. Guidance is defined in Statute 213.119J. Tourist and scenic historic excursion operations mean railroad operations that carry passenger from convenience to conveyance of the passenger to a particular destination, not being principal purpose. These operations run less than frequently than intercity commuter passenger trains occur, most often than short line railroads. And if a track owner has an operation of this type, the tracker does not want to take the operation in action at determining inspection frequency. The owner must drop at the track of the speed 1 class with regarding to the operation. This way, the track owner will be still in the compliance with the inspection frequency mandated by the table of the paragraph G6.1. Regardless of the class rate the owner runs on the track. The freight owner runs on the track. The first footnote of this table, the G6.1, states whether the 2 different possible intervals of the requirements of the frequent inspection intervals apply. 4. All continuous welded rail joints that are located with the switch turnouts, tracking across the rail assemblies, other transition discovered devices, movable bridge must be inspected on foot at least monthly, consistent with the requirements of Statute 213-235. All records of those inspections must be kept in accordance with the requirement of 213-241. Track owner may include the Statute 213-235 inspections of the lieu of the joint aspects required by the paragraph G6.1. The continuous welded rail joints that are located with the track structure that are adjacent to the switches turnouts provided with the track owner precisely defines the parameter of the arrangement of continuous welded rails. Alright, guidance. The paragraph accepted the following item of the periodic inspection frequency, intervals, switches, turnouts, track crossings, if lift rail assemblies, other transition devices, movable bridges. The track owner already inspects these items on a monthly basis pursuant to Statute 213, 235, rather than additional periodic inspection requirements applied to the intervals of Table 213, 119G61 to switches and turnouts, etc. FRA believes the appropriate to track the owner to conduct the inspection of the joint as those locations during the monthly Statute 213, 235 inspections. The FRA has historically understood operated with the assumption that the turnout extends to the point of the switch of the heel of the frog. Inspectors should continue to operate under the assumption accordingly that all joint turnouts, switches, etc. must be inspected monthly. Pursuant to Statute 213, 235, records of these inspections must be kept in accordance with Statute 213, 241. Regulation does not require the data elements listed in 213, 119G71 appear on the Statute 213, 235 inspection record. All the joints extend by the point of the switch beyond the heel of the frog must be inspected with the frequency intervals identified in the Statute 213, 119G61. However, the track owners are free to include in their monthly Statute 213, 235 inspection these joints that are located in the track structure, the adjacent turnouts or switches. The track owners chooses to do this, they must clearly define the parameters arrangement of the continuous welded railroad plans. In other words, the track owner should clearly identify the physical limits adjacent to the track structure, e.g., installed joints until the signal. They must clearly identify the inspection interval with the joints adjacent with e.g., inspecting all insulated joints to signal during the monthly 213, 235 inspection. Figure 19 shows the jointed track with a non-continuous weld rail joint on turnout, frog, and switch joints, points. Okay, in addition, as long as the owner clearly defines the parameter of the continuous welded rail plan, the track owner need not to keep the two sets of the record of the Statute 213, 235 inspection, record of the Statute 213, 119G61 inspection. For the inspection adjacent joints, for example, the track owner of the continuous welded rail plan indicates the joints of the crossover between the turnouts must be inspected during the monthly Statute 213, 235 inspection. Railroad track inspection of the joint over the crossover during the monthly Statute 213, 235 inspection, then it is sufficient if the track owner to create and maintain only Statute 213, 235 record. FRA believes the option fully is useful because it avoids confusion and duplication that might otherwise result. In addition, the FRA notes that it would be burdensome for the track inspectors to inspect the adjacent joints monthly and make note of the inspection in the monthly 2 Statute 213, 235 record, also required to be an additional of the 213, 119G61 recorded every couple of months. 7. The special record keeping requirements related to the joint bars of the continuous welded railway include the following guidance. The paragraph requires the track owner to keep the records of specific continuous welded rail joint bars. For FRA has distinguished between the two major categories of the records retaining periodic and follow-up inspection and 2 fracture reports. Alright, the track owner shall keep the record of each of the periodic following up the inspection recorded to be performed by the track owner's continuous welded rail plan, except those inspected and conducted pursuant to Statute 213, 235, for which the track owner must retain with the record pursuant to 213, 241. The record shall be prepared only on the day of the inspection made assigned with the person making the inspection. The record shall include the minimum of the following items: the boundary of the territory, inspected nature, location, deviations of the joint requirements of the part or the track owner continuous welded plan, the location identified with sufficient precision, with the personnel code returned with the joint identified with its ambiguity, the date of the inspection, the remedial action, corrective action, or both that has been taken or will be taken to have the name and the identification number of the persons who have been made the inspection. Guidance. The paragraph addresses the inspection reports that have been created after a periodic inspection required by paragraph G61. The following up of the inspection required by the track owner's continuous welded rail plan. The inspection reports the periodic inspection shall be prepared on the daily inspection is made and are contained and the required information. The periodic inspection recorded can be combined with other recorded records pursuant to Statute 213, 241. 2. The track owner shall generate a fracture report over every cracked and broken continuous welded rail joint bar that the track owner discovers during the course of the inspection conducted in pursuant to Statute 213, 199G, 213, 233, 213, 235 on the track required under 213, 119G6 to be inspected. The paragraph requires railroads to submit the fracture reports to the headquarters staff. Railroads should complete the fracture reports when they find cracks during the routine inspection pursuant to Statute Statute 213-119G and Statute 213-233 and 235 on the track that is required on record under Statute 213-119G61 to be inspected. The FRA in bold, this is in bold, the FRA intends to use fracture reports to collect the continuous welded rail joint data. The FRA does not intend to use the fracture reports for enforcement purposes. Inadvertent errors of the fracture report submitted to the railroad employee should not be subject to civil penalties. Then it goes on. Inspectors should encourage the track owners to complete the fracture reports whenever the cracks are discovered. In addition, with required inspection, the track owner is not required to complete the fracture report for the cracks found in exempted tracks, Class 1 track, Class 2 track without passenger service. However, the FRA encounters the repeated failure prior to the completing of the reports on a persistent recurring pattern of non-reporting. Inspectors can inform the regional specialist of non-reporting. The regional specialist will confer with the division staff to determine the appropriate enforcement action. Track owners are not required to keep the fracture reports pursuant to the requirements of Statute 213-241. However, the fracture reports are to be kept until the track owner received information confirmation from the headquarters of the data that has been received. The FRA currently has provided 4 options for the means of the track owner to submit the fracture report. The first option is through electronic data submission using the extensible markup language or XML format. The option always uses the railroad to decide how best to capture information. You still submit the FRA in standard valid way. The railroads can submit the FRA sending the XML directly to the FRA via the email. The second option is fileable in PDF with the file of Adobe PDF to capture the submitted with the data. The railroad can complete each of the reports, submit the Adobe generation of the CXML to the FRA via with the submitted button located on the form. The third FRA was made to be affordable with a sorted XBL Excel spreadsheet in which the railroad can input the fracture reports. Spreadsheets can be submitted via email, electronic media operated with the FRA Office, the Safety Analysis website. As final option, the FRA has available the printable version of the office maintenance budget approved fracture report from the download. More specific instruction regarding submission of the report available at the Office Safety Analysis website at the following address. 2A. The fracture report shall be prepared on the day that the crack of the broken joint bar is discovered. The record shall include a minimum railroad name, the location of the joint, and is identified by Malapone subdivision, the class of the track, and the annual million gross for the previous calendar year, the date of discovery of the crack of the brake rail section, the type of the bar, in standard insulated compromise, the number of the holes in the joint bar, general description of location of the crack of the brake, and the visible length of the crack in inches, the gap measurement between the rail ends, the amount of length of rail end battered ramp on in each rail end, the amount of the tread mismatch, the vertical movement of the joint in the curves and spirals, and the amount of the gauge mismatch lateral movement of the joint. Alright, guys, the paragraph requires that the fracture report is prepared on the day of the crack, broken, continuous welded rail joint bar is found. The fracture report is completed whenever the crack or broken joint bar is discovered during the periodic inspection required in Statute 213-119G61, as well as those required in Statute 213, 233, and 235. The annual gross million ton of information required for the fracture report can be entered on the report. Appropriate employee railroads, such as the railroad track inspector, may not have ready access information, even though the inspector should have been implied aware of the range for which the value falls. As a result, instruction provided with the concerning the frequency inspection of the required. 2B. The track owner shall submit information contained with the fracture reports to the FRA Associated Administrative Safety twice annually by July 31st, periodic preceding 6-month period from January 1st to January 30th, and by January 31st. The preceding 6-month period for the July 1st to December 31st. The paragraph requires the track owner to submit the information contained with the fracture report twice annually to the FRA. The FRA collecting the fracture report data will review the analyze to better determine the root cause of the joint failure. In addition, with the FRA inspected, will be expected to submit the FRA the fracture reports when cracked with the broken continuous welded rail joint bars, as found during the inspection of the defective exemption of the railroad's continuous welded rail plan. In addition, with noting the defective of this rail, however, the one fracture report is to be submitted to the defective joint. If the FRA inspection is not the only one of the required time that a railroad must submit a fracture report, but the railroad may voluntarily complete the form. Therefore, the FRA will not submit the form. Inspectors to complete the reports on the fileable PDF form, which can be found with the FRA's Office Safety Analysis webpage under the toolbar and identifying continuous welded rail. The submitted button will email the above Adobe-generated XMLs of the file predetermined address. 2C, after the 1st of February 1st, 2010, any track owner may petition the FRA to conduct technical conference to review the fracture report data submitted by the December 2009 assess whether to continue needed with the collection of the fracture data report the track owner and submit the written request of the Associated Administrator of Safety requesting the technical conferences explaining the reason for proposing discontinuing the collection data. Guidance: this paragraph allows any of the track owner of the FRA after the 1st of January 2010 to conduct a technical conference to assess that there is continued need for the collection of the fracture report data. During the technical conference, the FRA would review the data collected with the analysis done to date and determine if sufficient data has been collected to enable the FRA to make the technical determination of the continuous welded joint bar failure causes and contribution conditions. This page is intentionally left blank. Alright, here is what we'll back out of this. Alright, your continuous welded joint burn and fracture report, type of the inspection: periodic joint inspection, track inspection, turnout inspection, other, railroad subdivision, milepost date, annual million gross ton, track number, track class, tangent, curve, spiral, degree, rail section, annual joint inspection, date of the last joint inspection, bar type standard, insulated compromise, field side bar, gate side bar, gap between rail ends, rail end batter or ramp or tread mismatch, joint vertical movement, if joint and curve spiral, gauge ramp, gauge mismatch, joint lateral movement, other comments. Alright, your fracture report instruction. Type of the instruction identified with the type of the instruction being informed that the fracture was found at least one of the box of the group must be checked. Railroad, FRA railroad reporting the code with the CSX or north-south folk 4-character alpha. Subdivision, railroad subdivision district, if none enter system 14-character code alphanumeric. Milepost, railroad designated milepost at the location of the fracture 7.2 characteristics alphanumeric. ABC 1, 2, 3, 4, 5, 6. Data found. The data fracture was found 8 characteristics month, double month, 2-digit month, 2-digit day, 4-digit year. Annual million gross ton for the previous year of the specific track fracture. An allowable range from 0 to 999.9 and exclusive. Track class: the FRA has track class fracture, 1 character numeric, tangent curve, spiral, inner, outline. It indicate whether the fracture is found on the tangent curve or the otherwise degree of curvature, spiral, inner or outer range. In an applicable tangent with the tangent otherwise curve and spiral, inner and outer curve checked and curve with an entered in 2.125. Rail section. Indicate each rail section compromising the joint and standard bar that entered 136 for the compromising bar. Enter. Annual joint inspection frequency. Number of the time periods for the walking joint bar inspection is performed. 2 characteristic number. Date of the last joint bar inspection. Date of the last walking joint bar inspection was performed. 8 character numeric day, month and day, and year. Bar type holes indicate the bar type standard insulated with the compromise of the bar. Number of the holes: 2 boxes, 1 each of the group must be checked, broken through. For each bar, the field gauge, the check the appropriate, the broken completely through the indicated location of the break, through the center, through the inner bolt, or the other location. For each of the bar filled with the gauge, there is no requirement for the checking. Any box that neither bar is broken, cracked. For each of the bar field gauge indicated with the crack location corresponding lengths, each bar field the gauge, the number of the boxes may be checked. The box checked with the crack on the 3.1 numeric. If other check with the test description can be 64 characters to the alphanumeric. Gap between rail ends, measure, record, and distance between the rail ends, and if the joint is pulled apart and separated, estimate the gap prior to the separation. Rail ended material, rail ended banner or ramp, measure the record the height and length of the battered ramp of each of the rail end record, and even if it's 0, see figure 1 method of measurement, check the appropriate box, northeast or the southwest, enter the battered ramp, numeric. Tread mismatch, measure and record the tread mismatch, and see the figure 3 method of measurement. Joint vertical measurement, record the vertical movement of the rail joint not on the track surface. Gauge ramp and curves the only measured recorded with the gauge ramp distance out of the length in see figure 4 for the method of measurement. Gauge mismatch and curves measuring the recording gauge mismatch see figure 5 as method of measurement. Joint lateral movement and curves recorded with lateral movement of the joint rail not gauged according to statute 213 and other components including any other objects condition that may have contributed to the fracture and 256 alphanumeric. Continuous welded rail joint fracture figure 1 method of measuring a rail ended batter measurement to be made on each rail end, not to scale. Inches long, inches high. Continuous welded joint bar fracture figure 2 method of measuring rail end ramp, not scale. Continuous welded joint repair measuring tread mismatch, not to scale. This is gauge side and field side. Method of measuring gauge ramp. Joint bar fracture method of measuring gauge mismatch, not to scale. Alright, guidance. The paragraph permits the track owner to devise an alternate program for the inspection of the continuous welded rail. The track owner seeking to deviate with the minimum inspection frequency specified in Statute 213.119 G6 should submit the alternative procedures and a supporting statement justification that the FRA Associated Administrator Safety Associated Administrator in the supporting statement. And the supporting statement that the track owner must include the data and the analysis established with the satisfaction of the Associated Administrator that the alternate procedures provided at least the equivalent level of the safety across the railroad. If the Associated Administrator approves the alternate procedures, then the Associated Administrator will notify the track owner in such appropriate removal in writing is written. The notification Associated Administrator will specify the data of the alternate procedure will become effective after the date the track owner shall comply with the avoided procedures. If the Associated Administrator determines the alternate procedures do not provide with the equivalent level of safety, the Associated Administrator will disapprove the alternate procedures in writing while determining and pending with the Associated Administrator. The track owner will continue to comply with the requirements contained in Statute 213.119 G6. Alright, technology including the frequently automatic track geometry service-sounded continuous welded rail management, including the prompt removal, some called temporary joint, may provide additional information required to vary ongoing integrity of the joints of the continuous welded rail. The alternative procedure provision in the final rule will allow the track owner to take advantage of these new approaches that these become available. The track owner shall submit the proposed alternated procedure and supporting statement, the justification, Associated Administration, or Associated Administrator. The Associated Administrator finds the proposed alternative procedures providing the equivalent higher level of safety, the requirements in paragraph G1 through G7 of the section. Associated Administrator will approve the alternate procedures, notifying the track owner in writing. The Associated Administrator will specify the written notification of the date on which the procedure will become effective, and after the date the track owner shall comply with the procedures. The Associated Administrator determines the alternate procedure due to not provided with the equivalent level of safety. The Associated Administrator will disapprove the alternate procedure in the writing, with the track owner shall continue to comply with the requirements of paragraph G1 through 7 of this section. While the determinant is pending with the Associated Administrator on the request submitted with the pursuant to paragraph G8 of this section, the track owner shall continue to comply with the requirements contained in paragraph G1 through G7 of this section. 119.8. The track owner shall have the effective comprehensive training program for the application of the written continuous welded procedure provision with a periodic retraining for the individuals designated under Statute 213.7 while qualified supervise installation, adjustment, maintenance of continuous welded rail track, and perform inspection of the continuous welded track. Guidance at railroad employees designated under Statute 213.7 qualified to supervise the installation, adjustment, maintenance of the continuous welded railroad track. Perform inspection of the continuous welded track must be trained on the track owner of the continuous welded track rail plan. The track owner shall maintain the record of the training of the Statute 213.7D. The RSAC Track Safety Standards Working Group is currently collaborating with FRA to provide the clearly guidance with regard to the provision for periodic retraining. 119I. The track owner shall prescribe and comply with the record-keeping requirements necessary to provide the adequate history track constructed with the continuous welded rail. At the minimum of these records must include 1. A rail temperature, location, date, the consistent welded rail installation. The rail record which shall be retained for at least 1 year. The record of the continuous welded rail installation maintenance work that does not conform with the written procedure, such as the record shall include the location of the rail maintained until the continuous welded rail is brought in conformance with the procedures. 3. Information of the inspection rail joints is specified in paragraph G7 of this part. The paragraph 1 contains the record-keeping requirement of the rail for the track constructed with the continuous welded rail, and minimum the track owner must keep the records for the items that are listed in paragraph 1.1 and 1.3. Paragraph 1.1 requires the track owner to keep the record of the rail temperature, location, and the date of the continuous welded rail installation. Paragraph 1.2 requires the track owner to keep the record of the continuous welded installation maintenance work that does not conform with the written procedure. Paragraph 1.3 requires the track owner to keep records of information on the inspection for the rail joints to specify paragraph in G7. G119J as used in this section. Action items means the rail joints condition of the track owner identified with the continuous welded rail plan pursuant to paragraph G3 will require application of the corrective action. Guidance. Action items must mean that the rail joint condition of the track owner identified the continuous welded rail plan pursuant to the G3 which requires the corrective action. Section 213.119G3 would identify the broad categories that these track owners need to address. The rail-ended, battered, mismatched track owners will need to identify the specific criteria thresholds in their respective continuous welded rail plans. However, the many inches of the rail-ended, the batter, and permissible amount of the mismatched railroads to take the corrective actions, which corrective actions must they take, and note that the broad categories are only those required minimum. The track owners are free to identify the additional category set thresholds for these categories. Adjusting de-stressing means the procedure by which the rail temperature is readjusted for the desired value, typically consisting of the cutting of the rail, removing the anchor devices, which provides the necessary expansion of the contraction, then reassembling the track. Buckling incident means the formation of a lateral misalignment sufficient with the magnitude constituting the deviation class 1 requirements specified in statute 213.55 of this part. These normally occur when the rail temperatures are relatively high and are caused by high longitudinal compressive forces. Corrective actions mean those actions with the track owner specifically in their continuous welded rail plans to address the conditions of actual potential joint failure, including the applicable repair restriction on the appropriate operation of additional on-foot inspection. Guidance. Note this item. Notice in this term is used in paragraph statute 213.119G5. Continuous welded rail means that they has been welded together in two lengths exceeding 400 feet. Continuous welded rail joints are joint directly connected with the continuous welded rail and be a joint segment rail between the continuous welded strings and those less than 195 feet apart, except the joints located in the joint section of the bridges. Guidance. The definition is intended to include the joints affected by the continuous welded rail joints and joints that are intended with the continuous welded rail, but additionally the temporary joints may not be directly attached to the continuous welded string, such as the insulated joint plug railing. As many bridges have been joint railed and designed with the definition that would not include the rail joints of bridges. Desired rail installation temperature range means the rail temperature range which specifies the geographical area which the forces of the continuous welded rail shall not cause the buckling incident with extreme heat or pull apart during extreme cold weather. The distributed track means the distributed with the road bed in the ballast section. As a result, the track maintenance and any other event which reduces the lateral longitude resistance of the track or both. Mechanical stabilization means the type of the procedure used to restore the track resistance disturbed the track following certain maintenance operation. The procedure may incorporate the dynamic track stabilizer, ballast consolidators, which are units of work equipment that are used to substitute for stabilization action provided with the passage of tonnage trains. Rail anchors mean those devices which attach with the rail and bear against the side of the cross tie to control longitudinal rail movement. The certain type of rail fastener also act as rail anchors, control longitudinal rail movement by exerting downward clamping force on the upper surface of the rail base. Rail temperature means the temperature of the rail measured with the rail thermometer. Rail medial action means those actions the track owner is required to take the result of the requirements of the part to address the non-compliant condition. Tight and kinky railway means the continuous welded rail exhibits minute alignment irregularities which indicate that the rail is in considerably amount of the compression. Tourist, scenic, historic, excursion operations mean that railroad operations carry the passenger and convenience of the passenger to a particular destination, not being principal purpose. Train-induced force means vertical, longitudinal, lateral dynamic force which is generated with the train movement, which contributed with the buckling potential. Track lateral resistance means the resistance provided with the rail cross-tie structures and against the lateral displacement. Track longitudinal resistance measurement means the resistance proved by the rail anchors, fasteners, and bell section rail cross-tie structure against the longitudinal displacement. Unscheduled detour operation means a short-term unscheduled operation where the track has no more than 14 calendar days. Notice that the operation is going to occur. And that does this reading for continuous welded rail joint.